Time for an experiment. The question was asked whether carbon dioxide pools above cola. Now, obviously, to some extent, you're going to have higher concentration of CO2 above cola. But to some extent, you're going to get Brownian motion, diffusion through gas, spreading it around the room. The question was whether significant pooling occurs. So the hypothesis is that cola exposed to the air in a basin, the actual question concerned a much larger volume in a much larger basin, but basin, will produce a pool of CO2. Now, the official lab way to measure CO2, to detect CO2, is lime water. It turns white when you bubble CO2 through it. I don't have lime water or pipes or all those little bits of glass tubing and so on, so I'm using a rather different method. These things. Tealights. Packet of 10 just bought, selected on the basis of the first 4 out of the packet, which is pretty arbitrary. They should all be identical, they're mass produced. Those are going to be elevated from the bottom of the bowl using more identical mass produced objects, pound coins. It's possibly not the cheapest way to elevate a tea light, but I can always reuse them afterwards. 4 pound coins in each bowl. One tea light with its wick standing up in each bowl. Now, cola is a pretty vague term. It turns out you can get a lot of things that are cola or very much like cola. This is Spar's own brand, 330ml, which is a whole lot cheaper than buying Coca-Cola or Pepsi. I don't know whether it's any good, but I don't drink the stuff anyway, so it doesn't matter. The experiment is going to be a simple case of lighting the tea lights, pouring in a liquid, 330 millilitres of a liquid, and seeing how long it takes the tea light to go out. One of them is going to be tap water. It was going to be boiled and cooled tap water. It's amazing how long tap water takes to cool down if you leave it in the kettle. So it's just going to be tap water. Some dissolved gas, not a lot, and it's really, really not fizzy. The other one is going to be Spar Cola, which should be giving off CO2. Possible they'll both burn for a ridiculous amount of time and I'll just be stood here waiting, but we shall see. So assuming they light. 1, 2. Right. These tea lights are not impressing me. I'll just give them a little while to get lit. Just make sure they really are burning. In chemical terms, the heat from that flame is melting the wax soaks into the wick, soaks up the wick and evaporates. Molecules of fuel mix with the air. Oxygen in the air reacts with the fuel molecules in the air when they collide energetically enough, which is why it needs to be hot. Fuel molecules break up, oxygen molecules break up, and they reform into carbon dioxide and water vapour. In fact, if you put your finger through the yellow part of that flame, you'll find unburned carbon sticking to your finger as well. That is hot, so it's got low density, so it rises, which draws in fresh air, and at least for a while these things will burn in bowls. They've had a while to get going, so water in this bowl, and already I'm seeing a potential problem. Those 4 pound coins might not be high enough. Just started to float, so I'm going to have to stop there because I don't want them to float away and disappear. Cola into this bowl. Fizzing like mad as it goes and giving off an awful lot of CO2. And that one's just started to float as well. So as of now they're both burning in very still air I turned off the central heating this morning just to make sure there wouldn't be convection currents from the radiator. But the bowl on the right has CO2 bubbling out of the cooler. It's actually bubbling most energetically next to the tea light. Possibly it's because the tea light is hot, possibly it's because it's standing on pound coins, which are a lot of rough surface area where bubbles can form. Possibly it's because it's standing on dirty pound coins that have been in my pocket. We may be here a while. I did get enough cola and enough tea lights to do this twice, once in still air and once with moving air. I've got a fan set up over there to blow air across these, so that if this flame went out really quickly in still air, we could see whether air disturbance would prolong the flame's life. It's just possible the flame's generating enough of a convection current on its own to disperse the CO2 and not going to suffer. It's also just possible that my knees are getting too old for all this kneeling on hard floors. From here, I think the flame above the cola is actually getting taller, which would mean what? Well, I'm bored. Sod scientific integrity. Let's see where the tea lights float. Ah, yes, they float right into the stream of water and immediately go out. That's the experiment. Screwed that up. Oh well. So I can add the rest of the cola to here without putting that one out. What I don't want to do is fill the bowl so high that the flame is actually above the rim of the bowl. But I think I can avoid that somehow. Just seems it's a 3 litre bowl. Oh well, there we go. Flame's still lit, but only just. Nearly died, but it's recovering. Very little energy actually being added to stir the gas around. Well, I suppose me waving my arms around while I do this is mixing the atmosphere. And again, flame nearly asphyxiated there. When the level in the bowl was lower, I could trickle this down the side so it wouldn't draw the candle towards it, but it's harder to do as it gets more and more full. Very nearly out. I can afford to zoom in on this and everything.